Imagine you're designing a brand new city. Before building the houses, you must decide how all the roads will connect. Computers face exactly the same challenge. The way devices are connected is called a network topology. Different topologies are designed for different needs. Today, we'll explore the 6 major network topologies using simple, real-life analogies. Now that we've seen what a network topology is, let's understand it a little better. The same computers can be connected in many different ways. A network topology is the physical or logical arrangement of computers and networking devices. It defines how devices are connected. The choice of topology affects the network's speed, reliability, scalability, and how easy it is to maintain. Let's begin with the simplest topology of all, the bus topology.
Why is it called bus topology? Is there really a bus involved?
Not exactly. But if you've ever traveled on a college bus, you already understand how a bus topology works.
Imagine a city with one college bus and one long road. Every morning, the bus starts from the first stop and travels along the same route. When the bus reaches a stop, only the student waiting there gets on. Everyone else simply watches the bus continue. At every bus stop, students check if it's their chance to board. Only those at that stop get in, while the journey continues. As the bus reaches each stop, students check whether it is their destination. Only the right student gets off, while everyone else stays on.
But what happens if the road is suddenly blocked? The bus can't continue its journey. Students waiting beyond the blockage never receive the bus because the road itself is blocked.
Finally, the bus reaches the last stop and completes its journey, just as every trip eventually comes to an end. Now imagine 2 buses trying to use the same narrow road at exactly the same time. They interfere with each other, creating confusion, delays, and a complete traffic jam. Now let's connect the college bus story to a real computer network. Just like the college bus travels on one road, a data packet travels along a single backbone cable. Each computer checks the destination address. If the packet isn't meant for it, the computer simply ignores it. The packet reaches the next computer, which also checks the destination address. Since the packet isn't meant for it, the computer simply lets it continue. The packet reaches the next computer. When the packet reaches the correct destination, that computer accepts the data and processes the information. At the end of the backbone cable, a terminator absorbs the remaining signal. This prevents the signal from bouncing back and causing interference in the network. The college bus story and the computer network work in exactly the same way. Every part of the journey represents a component of bus topology. The single road represents the backbone cable. It is the main communication path of a bus topology. The college bus represents a data packet, carrying information through the network. Each bus stop represents a computer, also called a node, connected to the backbone cable. The students represent the actual data being carried from one computer to another. Bus topology is ideal for small networks, where only a few computers need to communicate. Since all computers share one backbone cable, bus topology requires less cabling than many other network designs. Installing a bus topology is simple. Every computer connects to the same backbone cable. The biggest disadvantage of a bus topology is its dependence on a single backbone cable. When 2 computers transmit data at the same time, their packets collide on the shared backbone cable. As a result, both transmissions fail. Let's quickly revise. In a bus topology, all computers share one backbone cable. Every data packet travels through the cable and reaches every connected computer. Each computer checks the destination address. Only the intended computer accepts the data, while all the others simply ignore it. Bus topology uses one shared backbone cable. But what if the network formed a complete circle instead? Let's explore the ring topology. When the token reaches a computer, it asks whether there is any data to send. If the answer is yes, the computer begins transmitting. To understand why ring topology works this way, let's look at a simple Monopoly game.
Imagine 4 friends playing Monopoly. Everyone sits in a circle, but there is only one pair of dice.
Only the player holding the dice can take a turn, while everyone else patiently waits. Every player gets a fair chance. Only one player can use the dice at a time, making the game organized and collision-free. Ring topology works exactly like this. Instead of passing a pair of dice, computers pass a special control signal called a token. When the token reaches a computer, it receives permission to transmit data through the network. After receiving the token, computer A attaches its data and begins transmitting it around the ring. The data packet travels from one computer to the next. Each computer simply forwards the packet until it reaches its destination. When the packet reaches the destination computer, the data is received successfully. After the data is delivered successfully, the token is released back into the ring, allowing the next computer to send its data. Since only the computer holding the token can transmit data, ring topology prevents data collisions and keeps communication organized. One disadvantage of ring topology is that if a single cable or connection fails, communication around the ring is interrupted. Now let's move to another widely used network design called star topology, where every computer is connected to a central device. Let's understand star topology using a simple hospital example. Whenever we visit a hospital, the first place we go is the reception desk. The receptionist is the first point of contact for every patient. Hello, I have a fever. The patient explains the health problem to the receptionist. The receptionist receives the information before deciding where the patient should go next.
Please visit the general physician in room 1.
Thank you. The receptionist identifies the correct destination and guides the patient to the appropriate doctor. Just as every patient first visits reception, every computer sends its data to the central switch. Even if one doctor is unavailable, the receptionist guides the patient to another available doctor. The rest of the hospital continues to function normally.
Now imagine the reception desk is closed. Patients cannot find the correct doctor. Even though the doctors are available, communication comes to a stop.
Now let's connect this hospital story to a computer network. Data first reaches the central switch. The switch then forwards it to the destination device. Each device has its own connection to the switch. This keeps communication simple and reliable. If one cable fails, only that device is affected. The rest of the network continues to work normally. If the central switch fails, communication across the entire network stops. Every part of the hospital represents a star topology. Patients are computers, the receptionist is the switch, and doctors are the destination computers. In a mesh topology, every device is connected to every other device. If one connection fails, data can use another path. This makes mesh topology highly reliable. Have you ever watched a football match? In football, every player can pass the ball directly to another teammate. There is no single player through whom every pass must go. If one player is blocked, the game doesn't stop. The ball simply takes another path through a different teammate. The team always has another passing option.
Now let's connect this football game to a computer network. Every player becomes a computer, and every direct pass becomes a direct communication link.
Multiple devices can exchange data at the same time. This improves network performance. Mesh topology needs many direct connections. This increases installation complexity. Because more direct connections, installation cost is more. Tree topology uses a tree structure. It connects devices in different levels. Data travels through different levels to reach the destination. Have you ever wondered answer script after an exam? It doesn't go directly to the evaluator. Instead, it passes through several levels, just like a tree topology. First, students submit their answer scripts to the invigilator. The invigilator takes them to the examination cell, where they're sorted subject-wise and sent to the correct evaluator.
Now let's connect this examination process to a computer network. In a tree topology, data travels through different levels, moving from one node to the next, until it reaches its destination.
New devices can be added easily in tree topology. Each branch can be managed separately, making the network easier to maintain. The major disadvantage is that if the main switch fails, the entire network stops working. Tree topology requires more cables as the network grows. Tree topology is commonly used in offices, schools, and large organizations. Hybrid topology combines two or more different network topologies. Imagine your college is organizing its biggest annual cultural fest. Different teams work together to make the event successful. That's exactly how a hybrid topology works. Within each team, members communicate through their team leader. Each team works independently, making coordination simple and organized. Just like a star topology, when different teams need to coordinate, their team leaders communicate through the event coordinator, instead of contacting every member directly. This keeps communication organized and efficient. A hybrid topology combines multiple network topologies into one larger network. This allows data to travel efficiently within each network and between different networks whenever needed. Hybrid topology is flexible, reliable, easy to expand, and provides high performance. Hybrid topology has a complex design and requires a higher installation cost.
Hybrid topology is widely used in large organizations, universities, and data centers.
From bus, ring, star, tree, mesh, each network topology plays a unique role in building efficient communication networks. Keep learning, keep exploring, and thank you for watching.